We're going to start and say we're going to start at range min y. Well, y is less than range max y. Y plus equals float. We're just going to call this the y cell size. And you know what? Let's just do this all at once. Cell size is going to be the range.max minus range.min, and we're going to divide it by the inverse of our resolution, which should be a float. And let's keep that an int. Range.max. Oh, but these are... Ah, gosh darn it. I'm outsmarting myself again, and I keep doing this. Not the end of the world, but... just a pain when it does happen. .x, and we just need to do this once for each direction. Resolution equals 1 over... this is the inverse resolution. There we go. This will keep us from doing a lot of our work multiple times. Let's see. There's x. And then we need to do this again. Did I just do this backwards? Okay, so we're going to find the difference, and we actually want to just multiply it by the resolution. Right? No. Because we want a cell to be less than the resolution. This is why I think these things through beforehand. Cell size.y. Much better. Do I need to think about terrain level of details and or access structures like quad trees for your terrain, or does the engine do that for me? Terrain level of details I don't, because I don't expect the user to be able to zoom the camera out far enough that I'll need to see a ton of terrain at once. And most of this terrain is going to be pretty... let's see, the terrain is going to be... I'm trying to think of the word. It's going to be a low enough resolution that I'm not really worried about needing a crazier level of detail. So maybe I'll come up with a level of detail system if it turns out I'm overloading the graphics card with too many vertices. But other than that, my big issue is probably going to end up being fill rate on any processor. And that honestly is going to be something I'm going to have to keep an eye out for in the long run. Cell size.x. Okay, so we've got our x and y. And we know what cell size looks like. So we're going to create a new range. We're going to call this the cell range. Yeah, okay. C4 range of 0.2Ds. The other thing I could do is, I've got x and y already passed in. I may not have to do it like this. I could just do x, y, and then size x, size y, right? This is the other way to do it that doesn't require this kind of information. But I kind of like it in this form as well. So let's leave it as is. Even though we're constructing kind of more objects than we need to, I'm not so worried about... I definitely am not worried about the way in which we're creating objects. So we're going to create a cell using the cell graph. pointer, and we're going to hand it a range 0.2ds that looks like, let's see, we need to give it, so we're going to have at least position. That's going to be our X and Y. And I guess I should just call this min, honestly. We're going to have our max, which is going to be X plus cell size.x and Y plus cell size.y. And now this makes this a little cleaner. Min, max. All done. Whew. So this should create the same size, but it should create 10 times. Actually, it should create 100 times as many cells. We might want to turn that down just for sanity's sake here. Cannot convert from, let's see, from a range to a constant range reference. Really? You shouldn't have any trouble doing that conversion. Create cell graph. Oh, whoops. Haha. It's not here. Also the other thing, the second half of Chakma's question, access structures like quad trees for my terrain, I will have to build those myself. But the engine breaks all of the cells into a visibility system. So when you do something like a, so not just a visibility system, but it also breaks it into an oct tree, which is a 3-dimensional quad tree. And so when you do stuff like array cast, or not array, when you do ray casting, there we go, that's the right word. When you do the ray casting, it suddenly will take your system and run it through the oct tree to make sure that the ray being cast isn't checked against every object in the scene. So there is some optimization done for me, but if I wanted to do a 2D quad tree version of this terrain, then I would have to make that myself. Danny Fritz is asking, does const in parameter type make it immutable? Yes. If you say something is a constant, and then you attempt to change it, for example, right here, I have this constant range. So if I go in and say range.min.x equals 2, the compiler is going to complain, right? X can't be modified because it's being accessed through a constant object. Cool. So, game world, let's fix the one last piece of the puzzle that the compiler is complaining about. You jump into build terrain. Build terrain then calls this range. Size and then cells per square unit. Let's think a little bit more. Minus size. So let's say size. We're not going to have it. So this is something that's kind of a big change that we have to keep in mind. Is that when you say size, size is now twice what it was before. Integer 2D. Integer int. Whoops. Int size. Integer 2D. Integer 2D. And you need to change in the build terrain function. There we go. Much, much better. DJ Beat says I'm thinking about it too hard. No such thing. No such thing as overthinking in programming. Fortunately and unfortunately. Whoops. not what I meant to do. Okay, so if we look at the wire, it's still a standard quad. Something's wrong. Something is bizarrely wrong here. Terrain generation. What's funny is it worked. What's not funny is that the way it worked. Cell size. What's the cell size look like? It's a 2x2 cell. Okay, it creates one cell. From -2 to 2, 2. That's fine. This is really bizarre. There it goes. It creates cell 3 and cell 4. Oh, we haven't modified our create cell function to use existing vertices. That's why we're creating some weird stuff here. Let's see here. How do we do this? How do we do this? You are going to be vertex array 4. I really wish C++ would do the C# version. I like that a lot better because that tells you it is an array of 4.2Ds as opposed to this. This just feels backwards to me. I don't know. You say it's a 0.2D and then you call it an array and give it the array specifier. Whatever. Vertex array. It's not the end of the world. It's just something funny you don't really think about too often. Vertex array 1 is this. We don't need that. Min max. Oops. Did not mean to duplicate this. Let's just do that. Better. It's usually the pointer to an element, so that type, right? So the C++. I think of it as part of the type, right? When you say something is an array, it's implicit that this is a pointer. This element here is a pointer to the array. I don't know. I think of it as part of the type and therefore should go before the name of the variable. Granted, a lot of people would call me crazy for saying such things, so And I am definitely crazy. I mean, come on. Well, granted, I guess I can't say anymore that I program for 8 hours a day at work and then come home and program more, because guess what? I didn't program. I don't do work anymore, at least not right now. Although I have some very big leads on where I hope to work next. So, yeah, also I guess the other thing to think about is that C# array is a type, versus here arrays are kind of a add-on feature that exists already. There's no type array. Array is just the square brackets are just an operator instead of a... Okay, I guess I can kind of understand it because of that. At least a little bit better. So, okay, we've got our array. And what we're going to do is we're going to say for int I equals 0, I is less than 4, plus plus I, usual for loop stuff. We're going to say cell graph, specifically if the cell graph vertex array contains this point, we'll call this cell vertex. Cell vertices. I like that better. Instead of calling it all vertex array, that seems a little messy. If this is less than 0, int, let's see here, vertex index equals this. If the vertex index is less than 0, then we add it to the array. Add element cell vertices I. So we add the new element in, and then we say the vertex index is now equal to it's 1 from the edge, because every time you call add, it tacks it onto the bottom. And so what we do in this case is we just say, take the length, remove 1, and that's our last element. Okay. And then, in this case, we then go into our... So we need to create the cell earlier. Step 1. Let's put that at the top. Yeah, let's put that at the top. Also, the other thing I just realized, I wonder if I can... Can I? Can I default initializer all of these? I would be really happy if I could. Oh, I would be so happy if I could. Sometimes you program things not knowing what they're going to do. This is one of those cases. No. Are you happy? Oh, that's so much better. I love it. I love it. There's a block editor line. There's a block editor multi-line editing function in Visual Studio. Really? I'll have to figure out how to use that. I know a lot of tricks about Visual Studio, but that is not one of them. Alright. C dot vertex indices add element vertex index. Alright. This is now duplicated. That's much better. So now we've got all 4 indices added in, not just to the cell, but we've got all 4 of these indices also being added into the cell graph. Let's see here. Cell edge. Oh god. Did I do this incorrectly too? Oh, that shouldn't be a pointer. This should just be standard. Crap. Well, there we go. And where else are you complaining? 6 errors. Can't be in that many places, can it? In fact, in this case, I'll just do this and then swap these back. And you actually, oh, where's the crud? You are now using edge. Edges dot, because this is passing references around, so I actually don't need to be doing all these dereferences, because dereferences are dangerous. Very, very dangerous. That I don't care for at the moment. From cell edge to cell pointer. So you're just not a pointer anymore. Ooh, but then I have to re-dereference it. That I don't like. So let's... Oh, and this is why I was doing cell edge, cell edge. Wait, why are you complaining then? That looks right. Oh, okay. It's not complaining. It's fine. You should not be a new call anymore. Oh, but... Okay. I keep making all these changes and I keep looking around, and we gotta make sure that all of these... Okay, this looks right. This constructor here. Let's just double check the other constructor. Okay, this constructor is doing what we expect it to. Good, 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 good. All that refactoring is paying off. Alt and select the lines. Okay, so if I want to do this and this. Alt and you and you and you. Whoop. You mean Alt? No, not Alt. Alt and select the lines. So if I do this and then Alt this, I guess I don't quite understand what you're talking about, H-Zapper. I need to look into that maybe separately. Do I think that a C++ game can be made with code blocks? I have no idea what code blocks is. No clue. That is something you'll have to fill me in on, Andy Pro. Andy Z Pro? Andy's Pro? Something like that. Sorry, I'm butchering Twitch names. I'm not trying to, I promise. It just kind of happens. Okay, so we've got all the vertices added in. Once all the vertices are in, we then need to check that every vertex, just hold Alt while selecting a block of code. Okay. So that gives me this. Whoa. That's kind of cool. That's actually really cool. I don't know what I'd ever use this for. Huh. I'll have to think about that. That's something I'll have to work with. No idea what code blocks is. I could do. All of my work, very true, has been working in Windows. Is code blocks a Mac thing? Is a free C, C++, Fortran IDE. Okay. Okay. Now I understand. Could you make a C++ game in it? I suppose. I mean, it's just an IDE, right? IDEs are little more than tools. As long as the language doesn't change or the compiler doesn't do things too incredibly differently, it should be fine. Okay. I'm understanding what you guys are talking about when using these line things now. I can now grab all these and be like, oh no, let's make them integer 2Ds now. That's cool. The only thing is that things have to line up perfectly for that. Maybe. Okay, so we've got our vertices. We now need to check that the edges exist in the cell array. So we're going to create the cell edge instance. We'll call this just cell edge. And I don't like that. Cell edge. I'll just call this edge. And I, in our usual I+1 mod 4, kicks in. Excuse me. And then we say if the cell graph edge array also contains, in fact, I should edge index. So if we can find the element using the edge, ooh, crud. Oh, but I've already written. Did I? No, I haven't. Crud, I need to rewrite this. Let's see here. We need to rewrite the operator, the equals operator here, because the one thing to keep in mind is that even though I'm using indices, these two could be in any order, as could these two. So we need to make sure that when we use the operator equals, that all of our edges line up, even if they're in somewhat different orders. And I haven't actually done an operator override in a long time, so I'm just pulling up some documentation so I don't look like a complete idiot on how to do this, because it was kind of, it's a little frowned upon to do operator overrides when you don't need to, because it changes how objects work in some cases. For example, if I override operator plus for integers, then I can really screw with whoever else is using my code. And I want to make sure that my code not only is readable, but is kind of logically sound. You should be able to just read the code and assume you know what's going on, instead of, oh, I see a plus, I'm going to have to look up the plus operator, which means a whole bunch of extra garbage. And that's something you don't want someone to have to do too often. Of course, oh, come on. Here we go. Basic equal overriding. Please. There we go. So it's going to be, we return a Boolean, and we take in a const edge, or I guess cell edge reference, that, I guess we can name this whatever we want, can't we? We'll call it other. Is this const as well? No, it is not. Which is really bizarre. Like, because this function is not a const operator, I can modify the innards of my own edge based on what the other edge is when you use a double equal operator. That seems like a really, really easy way to shoot yourself in the foot. Override, yeah, override int plus int to be int plus 1. Drive your coworkers crazy, and then get fired immediately afterwards. That's a great way to do it. Did I put this in the right class? I did. Cell edge, cell edge. And yeah, sometimes I have to look up things I haven't used in a while. For example, let's see, cell edge. I think this is how this works. Return true. Yeah, I don't see it complaining. It looks fine. Cool, okay. So obviously this isn't what we actually want to do. We want to return, I shouldn't have to type return twice. We want to check whether our vertex 1 index equals other vertex 1 index and vertex 2 index equals other dot vertex 2 index. Or, I guess I should put this on a new line, because this is going to be a big bitwise statement that we need to, or not bitwise, but conditional statement. Vertex 1 index equals other dot vertex 2 index, and vertex 2 index equals other dot vertex 1 index. Okay, so that's kind of the most obvious thing that we can do. We haven't set cell innards yet, I don't think. Is it good practice to always inline your simple operator overloads, or do you expect the compiler to do that for you? The simple ones I expect it to do for me, although then again I probably shouldn't, honestly. I've heard a lot of bad things about various compilers and how they work, and so sometimes it does make me a little jittery to sit here and expect a compiler to do something. That said, I never took a class in compilers, so for me, those are big magic black boxes of doom that if I were to ever try and take a look at the inside of one, my brain would probably explode. For me, they're just magic, hand-wavy, like, Lovecraftian horrors, and I've just never taken the time to learn that. And that's something that, aside from HLSL assembly and some C++ assembly, I do wonder how those work, and I really wish I could have the time to sit down and try and like work on a compiler, or at least see the innards of it, just to see how that sucker works. That would be a cool endeavor to do. They're stupidly simple, are they? I have no idea. I would not know that. Okay. So, yeah, so we've got our edge, and we're going to make sure, first off, that it exists somewhere else. Also, this is not right. Int cell index equals cell graph get, not get cell, just cell array get element count -1. No, just get element count, because we haven't added this cell into the index yet. Dum dum dum. Cell index. So the thing I'm thinking about here, and the reason I'm like sitting here staring, is that right now, if you look at our definition for what the operator equals does, you'll notice we're only checking vertices. I'm not actually checking cell indices as well. And the reason I'm not checking those right now is because we're going to be filling those in as we go. And when I create an edge, I'm actually unsure about whether or not each of these edges is going to have certain details filled in. So I think I just need to write a function to do this, because otherwise I'm going to be writing this operator equals, and it's not going to do fully what I expect it to do. So I'm actually going to remove this. As much as I like it, I'm going to remove it, and we're going to swap over to something else. Something, let's see, the cell graph will probably be a better place for this. Get cell edge based on the two neighbors, close. Int get cell edge index. And we're going to base it on vertex 1 index and vertex 2 index. And we're just going to do this by hand. It's kind of the best way I can think of doing this without writing code that kind of messes with or changes our understanding of how the code should be working. Get cell edge index, and this is in the cell graph. Because what I don't want to do is leave that... I don't want to leave that double equal operator as something that doesn't make any sense. I don't want to leave it as something that would possibly kind of possibly break something down the line because I forgot about it. Would I consider streaming while coding a form of rubber duck debugging? I've done it before. I'm not proud of those moments, but I definitely have done it before. Where could I see? Where could I see some of the game in action so far? You'll see it a little bit. I guess so. My YouTube channel in the description has previous streams that I've run, and those previous streams are definitely those have a lot of gameplay in them, and they have a lot of the current gameplay elements as well. So that's a good place to look. Lincolnberg. Working on my pronunciation. Please tell me if I get something wrong, although I'm not really sure how you correct me. Alright, so get for int I equals 0, I is less than our cell edge. Is it just an edge array? It just is an edge array. Plus I. And we're just going to look for this simple thing that we built earlier. Somewhere up here. Cell edge. This. That ugly thing. Well, it's not ugly, actually. That's pretty... It's not bad. In terms of code I've written worse. That much is unfortunately true. Cell graph this. Specifically, if these are equal, and let's just pull the cell edge into its own variable. Vertex 1 index. Oh, whoops. I missed its name by a little bit. Not the end of the world. That or that. If this or this, specifically, there should be some parentheses around this block. Return I. And if we never find it, return -1. Cool. Get cell edge index. So we actually don't even need this now, which is really cool. We say int edge index equals cell graph get cell edge index based on I and this I+1 mod 4. And now we should have an actual edge index. If edge index is less than 1, or is less than 0, sorry. That would be bad. Then we say the cell graph, edge array, add element, cell edge. We have to add in I plus 1 mod 4. Ooh. Oh crap. It's not just I and I plus 1 mod 4 anymore. Let me think about this. Because it should be not I anymore, right? Our vertex 1, I'll just call this vert 1. Vert 1 is going to actually, and it's vert 1's index, is going to be pulled from the cell vertex indices I. And vert 2 index, I have to remember these things, otherwise I'm going to lose my mind here.
Leave it.
I plus 1, this is where the I plus 1 mod 4 kicks in. And when we do this, it should be this, and that. Once again, this goes here, this goes here. The dump, and then we have the edge index equals cell graph, edge array, get element count. Actually, haha, if we switch our order, we can make our life a little easier. There we go. Vertex, yeah, that's much better. I like that. Cleaner, better. Hey, I can read ancient Hebrew apparently. Yeah, chakma. Do any of the data structures in this framework support iterators? Yes, yes they do. The reason I'm not using iterators, in most cases I like to have indices, especially when I'm looking through something like, well in this case I need an indice in this loop so that I can pull the next indice as well. This, could I get away with it in here? Maybe. Maybe. I'd have to think about it. I do use indices from time to time. I tend to use them on lists and arrays in which I already know the object type and I know I'm not going to be modifying anything, or I'm just going to be using the objects inside and calling functions on them instead of doing anything too crazy. But they do. Pretty much, I think most of the basic ones in the engine do actually support the iterator stuff. At least the C++ 11 iterators. Whew. Okay. Cell dots edge indices, add edge index. Woo! Okay, so we've got vertices, we've got edges. Oh, the other thing to keep in mind, if we do find specifically, so if we don't find the old one, that's not the end of the world. Cell edge pointer equals cell graph edge array plus the edge index. But the one thing we do want to be doing in here, oh, I need to give it a name, huh? Edge pointer. Let's see here. We need to set the, let's see here. Yeah, we need to set the other cell index. So edge pointer, I guess first we can do a little error checking here. So if multiple edges are trying to use, if it's greater than or equal to 0, we've got a problem. Specifically, I guess I can just say if it equals -1. Engine, report, multiple, let's see, multiple edges? No, multiple cells attempting to, not multiple, more than 2 cells attempting to use a single edge. Right? Edge is a line, 2 sides to the line. If anyone else attempts to use more than that, we have a problem. I'm only going to report it just in case, but that's still something good to have. Also, that requires me to include, come on, pound, there we go. Much better. Oh gosh, here's a username I'm gonna like completely butcher. Stefaleksovsky? It's a mouthful. Stefaleksovsky. Haha, I think I got it that time. Why don't you use a game engine? I am. If you do, what is it? C4 game engine? It's in the description below. Back to work. Back to work. Alright. So you'll notice I'm writing a lot of code. I'm going to have to double check a lot of this. But edge pointer cell2 index should be our cell index. C.edge indices. Good. So now we've got our edges and our vertices all put together. I don't think there's any more information I really need to throw into this. So this can bugger off. And then we just add the cell to the array at the end. Alright, let's check this out. Cool, and it compiles. Ooh, when it compiles the first time, that's a great feeling. So index 0. Right now we are going to generate all these 4 vertices and none of them are going to be in the system. And the vertex index 1, 2, and 3. And then none of these edges are going to exist either. So we're going to add 1 edge, 2 edges, 3 edges, 4 edges. Good. And then we add the cell. And then we do it again. Whoops. That's not where I want it to be, though. Let's put a breakpoint here. Okay, so this looks like it's working. The only thing I want to double check. Okay, so we found a vertex that exists. And then one that doesn't. One that does. Or no, sorry. That's another that doesn't. And there's one that does. So it shares 2 edges. That doesn't seem right. Your vertex arrays don't make complete sense to me. Okay, let's grab this expression real quick. Tell me what your 4 values are. 1, 4, 5, and 2. So 0, 1, 2. And we went across on X. There should really only be 1 shared vertex here. Let's just see what this looks like. Watch, this will be a mess. Wait. More than 2 cells attempting to use a single edge. Yes, there's a problem. Although what's funny is it looks like it works right. Looks like it's fine, right? Our resolution is 2 cells per 1 object, and we have 1 object in the scene. So it looks like it's working. I don't know. Alright, we'll do a quick debug of this. And what I'm gonna do is, once I've got this debugged, I am starved. Or I will be, at least, by the time I'm done debugging this. So I'm gonna run off, get some food. Probably continue this tomorrow. Tomorrow, sorry. I don't know why I felt the need to say it that way. But, let's see here. I'm grabbing my trusty pencil and paper just to make sure that all my details are correct. I'm even scratching out all my old Verneuil work because screw that stuff. And yes, I do have 4 things on the screen, which is really bizarre, right? It worked, and yet there are errors. That's frightening. Honestly, that error should never be getting thrown. So, I don't know what's wrong. Let's see. Each time we add a vertex, we'll put a breakpoint there. Each time we add an edge, we'll put a breakpoint there. And then obviously on the end of this statement, we'll put another breakpoint. So we can see exactly what it's trying to toss in. So And let's put some watches in place that are actually helpful here. So we have the cell vertices I. That's going to be a useful one. Just so we can see what we're adding, and then we can later on figure out some other useful things. So I'm just going to draw 2, 2. This is something like what it should look like, I guess. Yay, pencil and paper, and I'm sorry you guys can't really follow along with what I'm staring at in front of me. I'm kind of tempted to do it in paint, but I have a feeling that would be more distraction than helpful at that point. Plus, maybe I can show you guys, can I? Yeah, look at that. I can show you guys. That's good. We can do this. Lol breakpoint. Yep. Happens a lot. But I put them in for a reason. So, okay. First off, -2 and 0. -2, 0. So this is what we're going to call V0. Because that is, yeah, vertex 0 just got added in. And then we've added in 0, 0 is now vertex 1. Vertex 2. In fact, let's just put vertex index right here. So vertex 2 is going to be 0 and -2. Okay. Vertex 3, -2, -2. So that makes sense, right? We've got one square getting set out. And that's our fourth vertex. And now we're going to start looking at edges, and none of these are going to exist. This is where I need more watches. I need vert1 index, and I need vert2 index. So between 0 and 1, so we've got a line here that exists. Between 1 and 2, good, nothing broken yet. 2 and 3, and 3 and 0. Okay. Done with cell 1. And we've got 4 cells. So cell 2, this is creating a very interesting tree. Because we're starting on the right-hand side, and we're going, I need to get this on camera correctly. We're starting on our right-hand side, and I'm going clockwise around, which is generating some interesting data. Also, music. Now is your time to shine during these quiet moments. Come on.
It's 5:20, babe.
I know.
Okay.
I'm keeping an eye on it.
Okay, just checking. Almost done?
Almost. So this is our fourth vertex. And of course, I hit F5 while I have chat selected. So that's going to kill chat for a moment. Sorry, guys. Or at least it's going to kill my access to chat. V4 doesn't exist. V5 is 2 and -2. Now V6 it should find. Right? When I go through, it should say, aha, this does exist. Because, and that's vertex 2 that it just found. And that's good. That's expected. And that's all? What? Was that? That doesn't seem right. What are your vertex indices? There's 4 of them. Okay, copy expression. U, comma 4. And it goes 1, 4, 5, 1, 4, 5, and 2. Okay, no, that's fine. That's right. That is perfectly fine. So at least the vertices are being created correctly. Does Visual Studio? Yeah, it is a compiler. Well, I guess it's an IDE. Yes, it includes a compiler though. Let's see here. Okay, so maybe it's our edge generation that's not right. It seems bizarre. Okay, from 1 to 4, that's fine. That's a new edge that's not going to exist. And then between 4 and 5 is right. Let's just look at this real quick. Cell 1, cell 2. Yeah, that seems fine. Oh, if it equals -1. Derp. So actually, this code might work just fine. Let's double check here. Of course, in doing that, I invalidated all of my data. But let's just... I'm actually even going to debug... Where are you? Delete all breakpoints. Yeah, code worked. I'm debugging something that's not broken. Woo! I love it when I do that. And that looks right. Right? This looks nice and simple and easy and done. So, let's just do a stress test here before we call this complete. So minus size to size, and that's called from our game world. And we can close these. And let's see here, range. So first up, let's turn up our resolution, right? Let's change it from 2 to 10. Step 1. Nice. Okay, I like this already. This is already looking a lot better than it was before. This will probably break something. Or if it doesn't, I'll be really freaking happy. Ugh. Of course, you can see it's taking forever, but if you look at that wireframe, look at all the pixels! All the little pixels! They're so cute. Holy heck. And there's color banding going on. It's so bad. What's my... Was it time? Yeah. Oh my gosh. Oh, man. That's kind of painful. 17 frames per second just for a ton of pixels? Alright. Well, I mean, that's a lot of vertices, and we're not doing any kind of clean fixing here. So, that's fine. Whatever. We're not doing any optimizations. And you can see, actually, it's the render time and the shadow time. They're both taking a ton of time. If I could turn off the shadows, I'd probably be back up to 60 frames per second without a thought. But, okay. So 100's overkill. That's fine. One thing at a time. We'll get us through this. Okay, so I like this resolution, 1 in 10. Or I should say 10 units per... 10 cells per game unit. That's fine. The other thing... I don't know, for that many vertices, I've seen models with tons more vertices. You'd think it'd be better with that. I don't know. We'll see. Also, Gizmo Gaming, yes, I'm using C++, but learning C# is a great way to get into game development, especially for a game design course. I think that's a great way to go. That's what I ended up teaching for one of my quarters at UC Santa Cruz, using C# and X and A, and I think that's a great way to go. 20,000 triangles. Why is that overkill? That honestly shouldn't be. I don't know why that is dragging my poor CPU to its knees. It might be because I think I have the terrain marked as dynamic, so it's resending not just every vertex, but there's color data, there's UV data, there's normals, there's tangents, all attached to that. So it's not just that, but it's also got a lot more data. Let's just do a quick calculation here. Calc, come here. Let's see. Okay, vertex, 3D data, so that's 32 bits by 3 components, plus normals are going to be another 96, right? Plus, let's see, what else do we have? Tangents, that's another 3D vector, so there's another 96. And then color is another 32 bits. Tangents, normals, and UVs. UVs are going to be 64 bits. So that's 384 bits times the 20,000 rectangles. We're sending across 7.6, well, actually, 1024. So that's kilobytes. Yeah, 7.32 megabytes per frame heading across the bus is way too much to be sending to a GPU all at once. Especially every single frame. These aren't in vertex buffer objects. These are all coming down the pipe at once. And that's going to be killer because it's also doing things like It's doing culling checks on all of those. It's trying to do... what else? There's probably a whole bunch of other visibility stuff. Also, it's trying to use all that for shadow mapping, so it's rendering it multiple times. So, I don't know. There's a lot to it. I can see why that much data can cause a little bit of trouble if it's not optimized correctly. We'll fix that later. We will be able to handle those large numbers in the end, just not right now. And I'll have to look into a little bit of the engine and figure out why it's unhappy with some of that as well. So the other thing is our terrain size is only 2. 2 units is not that great. Let's try a 10 square unit first, and then go from there. GPU bus is pretty darn quick. Nice. Okay, I like this better. The only thing is I probably want this to be a little higher resolution still, in the end. 100 was overkill. Let's try 20. Oh, also, shouldn't that... Wait a minute. Wait a minute. I just realized my terrain size got larger, and my resolution just spread it out more. I think I need to figure out how to do this on a per... Because I want all of my tiles to look like this, right? I don't want them to actually be big, giant things. So if I make this 10... I think this should be... Should this be range over a single cell? Let's see. What size should a cell be for a given range? Because this is given that I want to make a certain resolution standard. So I guess this would be inverse resolution times that distance again? That seems odd. Oh, it's because I'm changing the cell size based on the incoming range. I just want to make this that. And now... Okay, we're having a little processing time here, but that's fine. Come on, any day now. What's going on here, guys? Max is 10. Okay. I know I'm dividing it by 1. I'm just going to remove the division for now. Take out the breakpoint. Okay. There we go. And a 10th is probably a little insane. Maybe a half would do fine. I think a 10th was just overkill. That's much better. And I still probably have a clean frame rate. Of course, I can't read my frame rate with the wireframes on. Yeah, okay. Keeping up with a good 220 frames per second. That is a decent mesh right here. I might want to turn it down once more, just to see how it looks, but otherwise, I think it should be good. Chugga-lugga-lugga. Yeah, that's a decent mesh. And I bet there's some optimizations I can do here to make it cleaner. So yeah. Right now I am using Visual Studio Express. The reason I haven't swapped over to Community version is that the big thing that the Community version adds is the ability to run plugins. And I keep looking at all the plugins and not really deciding I need anything out of the plugin list. So far, I haven't seen anything worth swapping over for. I'd rather be developing games than playing with what IDE I'm using. I also, let's see here. How do you access the Profiler Visual Studio? I use Very Sleepy, same as Chakma actually. I really like that one. It gives you a good sense of how much time is being spent in what functions, and if you give it the debug information, it's actually really good at pulling apart who is calling what and how much time that code is taking up. I used it a lot for some of my file creation stuff. I had to do some file creation optimization, and Very Sleepy was a fantastic way to get around that. I plan to make a simple little 2D pixel platformer and stuff. Is it good for Visual Studio? Yeah, Visual Studio is great. Ugh, that's a good pop. I want to make it platform because my school uses Macs. That's a little more difficult. But I guess an executable should run the same, right? Except for any functions you're calling in terms of like Windows-only functions. Obviously, that kind of stuff you need to swap over to a Mac type when you do that. Going to try and model art. Good luck, Gizmo Gaming. 3D modeling I find stupidly difficult, but I'm also just a programmer, or I'm a much better programmer than I am artist. So, meh. I have trouble with my Blender stuff. It's just not that great for me. Yeah, kernel mode drivers are not anything I ever touch, but I can understand how that's really, really cool for Visual Studio Ultimate. At the same time, yeah, each time I look at the other editions, they have some nice features and then some stuff I really don't care about. I used to use Visual Assist pretty much as the only plugin I can think of for Visual Studio. And Visual Assist was really nice when you're doing something like digging through someone else's game engine. But I don't know, I didn't do a ton of that. Well, I guess I didn't do a ton of that stuff in my second job. And once I got used to my own code, I didn't really need Visual Assist for much in the game engine either. Just personal preference, though. Alright, guys. I'm hungry. We've done the basic steps here. There's one more thing I want to look into. Also, I'll take some questions while I'm digging around for this last little fixer-upper. That is where I'm setting biomes. Where's the biome code? Here's our biome stuff. Well, there's the biome color stuff. I need to figure out where the biome code is. Oh, is it not getting done anymore? Create cell graph. I think I need to go through each cell as I create them and set that data as well. Oof. Let's do this. Since I've got a cell, can I return a cell pointer? Do I want to return a cell pointer? Yeah, why not? Cell pointer. And we just need to add this here. Cell pointer. Create cell. Cell pointer. Good. Let's see here. Return cell graph, cell array, get element count -1, cell graph, cell array, plus, thank you, Visual Studio, that was completely unnecessary. There we go. So this will give us the cell pointer of the last object that we just created. And what we can do with this information, cell pointer cell, is this cell biome type. Actually, we should probably just do this in create cell, shouldn't we? Crud. I did all that extra work and didn't really need to. Oops. Let's nuke this. And this is overkill. So let's get rid of that again. Not a void pointer. That would be bad. Void. Yep. Back to you. And finally, in the terrain generator, before we say everything is said and done, we need to go into the cell and set the biome type, and we also need to set the elevation. Elevation's easy. Or I think it's easy. Is it easy? Yeah, we call get terrain height for... Oh crap, but we need to generate a biome first. How was I doing biome before? And this is where diffs come in handy. I'm not... Cell, controllers, game world, somewhere in here. No, that's not what I'm hunting for. And you guys, I just realized, can't see what I'm doing. Let me pull up Visual Studio so I can... Terrain generator. Here we go. Okay, so this goes through all the cells and generates a type for it. And that is kind of what we want. That's going to generate garbage, though. Create cell. You know what? We're not going to use an offset for now. So this is just going to be standard stuff. Also, this should not be in a for loop, because we're just setting the current cell. So actually, even this can bugger off. C.origin.x and C.origin.y. And that will be our noise. And then we say C.biome is this. And because we have the function, I may as well use it. Game utils floor to int of the noise value. And then we're going to convert that into a biome type and store that. Then the other thing is we're going to jump in here. Look at, oh, holy heck, you guys have been talking. Can you compile, multiply? Okay, cool. Nothing that concerns me. At least, it concerns me, but lightly. So this just becomes C.elevation. And actually, there is no offset right now. C.biome type. C.origin. And finally, our offset, which right now, is that just, yeah, C4. Vector 2D with zeros. Hooray. We don't need that. There we go. This should be interesting. This should actually generate something worth looking at. What? Cell.terrain node. Oh. What? Wait. What? If. Oh, crud. Let's disable this code. Let's not call that create water geometry. Where are you? It is almost time to write it to do an eat. Almost. /star. Let's turn this off at bare minimum. I just want to see this one thing. Come on. Oh, look at that. It begins again. Here's our nice flat plains. Here's our all of our forests, and you can see it's casting shadows nicely. The mountains have a little see-through section, but we can fix that. And that's not bad. We're still above 60 frames per second, and this is completely unoptimized terrain. Also, this is the joy of... Oh, that's interesting. For some reason, the mountainous terrains are causing more time to be spent in the shadow mapping section than the other bits of terrain. Huh. Alright. Guys, thank you again for joining me. It's time for me to go eat. But we're kind of well on our way to rewriting stuff. And we're getting to a point now where we're getting to the point where we're starting to see some progress on rewriting the terrain engine. And this is just kind of a simple, basic thing. Ooh, here comes the fog. This should be really interesting to see. Especially around these sections of forest where you can see it dipping down a little bit. That should be really cool too. That's actually neat. I really like this. We'll play with it more, but still. This works. This looks neat. And we're making some good progress. Some really good progress. So thank you again, guys, for joining me. If you like what you see here, today has been a kind of interesting change because usually I'm adding new features. Today I'm ripping out an old feature and putting a new one in its place so that we have something a little more dynamic and interesting here. So in this case today, we're doing some interesting stuff, but it's not the usual. This won't be the norm. Granted, I still have some more work to do on this before I go back to what was the norm before. So thank you guys for joining me. Please follow me if you like what you see. It's great to have all of you along for this. And even though this is kind of a basic thing, we're going to get into something a little more advanced in the terrain generation world next time, hopefully. So thank you again for joining me. I'll catch you guys later. And just to really quick clear off, I saw a new... I don't think I'm using C++ 14. I can't even think of a real compiler that uses 14 features. So I still use new and delete all the time. And you'll see one thing that you haven't seen because you just joined, but the engine actually has new and delete overridden so that it uses memory blocks, which is much more efficient than your standard new and delete. So it's not the end of the world for me to be using new and delete because the engine I'm using is awesome. Alright, thanks again guys for joining me. It's been fun, and I'll see you all next time. Peace.